Hello, everyone. My name is Kevin Tarr. I am an iOS engineer, and today is day 35 of Algorithms of Swift. So today we're going to be doing another problem off of LeetCode, and it's going to be ranked hard. Okay? I know I did that hard. But anyway, well, actually, I do know why I did that. So, um, guys, don't take rankings too seriously. Rankings are just somebody's opinion of the problem. Some problems that are ranked very easy on LeetCode are actually very tasking and challenging to a person, to a programmer. Other problems that are ranked hard are actually quite easy. I think this is one of those problems for me. This problem is actually quite easy and quite straightforward. Um, but it's for finding the first missing positive integer. So we look through an array of numbers, an array that could have negative and positive numbers, and we find the first missing positive number. It's as straightforward as that. They do use obtuse language, dealing with unsorted arrays and everything that I think is intentionally and purposely meant to confuse you and perplex you. But if you understand the root of the problem and the root of the question that's being asked, I think you have no problem solving this. So without further ado, let's solve this problem. Our problem states, given an unsorted integer array, find the smallest missing positive integer. Okay, so this problem is obtuse for no reason, in my opinion. I think the unsorted part is meant to, further confuse you or to scare you. But basically, we have to find the first missing positive in an array of integers. So it can have negative numbers, as you're seeing in some of these test cases. Um, it got positive numbers. Your algorithm should run in order and time. And use constant extra space. So our algorithm has to run a good space complexity, constant extra space, um, which brings me to a good inflection point. So the naive approach would just be to count one by one using an array and seeing if getting a numbers from one to the highest positive maximum and going through it one by one and asking if the array contains that number. If it doesn't contain it, then returning it. That runs in order and time, but that could be very computationally expensive, especially if we have an array of 1 billion numbers, which integer, the range can go up to 1 billion actually. I think it goes up to positive 2 billion and negative 2 billion, that range. So it's very well, we could very well be dealing with a very excessive and exhaustive test case. Um, but we can use that same logic. The logic is not wrong; it's just naive because it's facile, it's superficial. What we could do is, with that same logic, we could find a collection type that actually runs in constant time, has constant lookup, and it's computationally inexpensive. And that's where sets come in. So we could use a set. We can convert the numbers into a set and do a simple while loop for numbers one all the way up to integer.max, which is 2 billion, okay? And we can ask if the set contains that number. If the set doesn't contain that number, we return that number. And since sets have constant lookup time, it doesn't take much effort or time at all for it to find that number. They run extremely fast and extremely efficient, time complexity wise and space complexity wise. So let's do that right now. Okay, so we create a copy of this, but we could put it into a set. Call this nums, and then var number equals 1, while number is less than int.max. If nums does not contain number, return number, and then add 1 to the number for every loop so we continue to iterate and increase. And then we add a return statement so that we can just the compiler will be happy, happy at the bottom. Okay, so let's run this. Cool. Okay. Let's submit it. Boom. Bravo. Okay. And actually, guys, we actually, to be more scrupulous about edge cases and interviews, you want to make sure that this actually has elements. You don't want to do all this work for nothing. So this is just being responsible. I don't think that our test cases for this problem need this, but in an interview, your interviewer is going to want you to be aware of these things, of edge cases. So return. So we can do check if the numbers is empty. If it's empty, um, if it's empty, we don't even need to run the problem. Okay, we just return one right here, and that saves us time in case we had dealing with an empty array and it's doing all this work for no reason, pretty much. So let's submit that again, and that works too, um, and it's faster. So yeah, bravo again.